This is test 3 2019, question 3B. In this case here, you're given a little picture of an electrochemical cell. So on the one side, you have your anode and your cathode, and they're showing you the species that are present within this cell. So the first part of the question wants you to pretty much write out what the cell notation is. So you're given a nice box to put it in there. So remember, cell notation is showing you all the different species and what they're turning into as you go. So you start with anode, going to cathode. So we could actually write this down first of all, what's happening. We know anode is an oxidation reaction, and our two species that we have present, every time I see platinum, it kind of means it's not really participating, it's just a surface in order to funnel electrons. So the two things participating are iron 2+ and iron 3+. So if this is the oxidation reaction, that means we're going from 2+ to 3+. So we're going in that direction. And over here on this side, so cathode is the reduction. So you would have silver plus going to silver. So write out the cell location then. Oops, this is part one. You start out with your anode and the actual electrode portion of it, add your species, and then you're going to do the cathode. So I'm going to put everything in here. I can see it all. So platinum, solid, specific here, you have to show all the phases. Then we have a phase boundary between the solid and the liquid or solution phase. And within the solution phase, then, we're starting with iron 2+. And you have to put, first of all, that is AQ and the concentration in there. So this is 0.1 molar. Now, to show that the other one is also in solution, we're going to put comma, iron 3+ now. And this is 0.2 molar. Now the separation between one side and the other, pretty much how this done, show that with a cell bridge or a double separation, showing they're actually not touching at all. And then over on this side, we have our silver ions, which are in solution, so aqueous. Oops, add your little AQ over here, going to solid silver. So now we have Ag plus AQ, and our concentration of that is 1 molar. And that touching the silver cathode, which is a solid. So here's your cell notation. Now the next part wants to know the half reactions, so the oxidation one, the reaction, and then the overall balanced one. So we already kind of alluded to this a little bit. Our oxidation one is the iron. So we have iron 2+ going to iron 3+. And to balance this guy out here, we're going to need to have 1 electron over here. Then we have silver plus going to silver. This is the reduction. And to balance this one out, going to have to add an electron on this side. And then our overall, nice and simple, is 1 electron in each case. So you can cancel those electrons out. And you're going to have iron 2+, silver plus going to silver, and iron 3+. So there's our balanced chemical equation. Now, in order to go on to part 3, so you guys have that one written down because I'm just going to refer to it then again in question 3 because we're going to need to know that. Okay, so part 3 is asking you to find the reduction potential from the iron 3+ to iron 2+ couple, okay? So in this case here, then, this is a reduction, right? The way it's written, just keep that in mind. It's not the way it's written up here. This is the oxidation, but this is how you would find it in the tables. So in order to calculate those out, remember our equation, knowing our cell, E naught cell is equal to E naught of the cathode minus E naught of the anode, because the anode will go in the opposite direction, oxidized. So we know this one here, we're given this number, yes. So we are given 0.80 volts for the cathode. Right out of the question, that's from the silver plus to silver. We don't know E naught cell, and we want to find this guy here. This number way up here that you're given, that's not necessarily E naught cell. So E naught means that it's under standard conditions, which means that all species are 1 molar in solution, and they're not in our case here. So we have to find E naught cell based on these other concentrations that we're seeing. So that brings us to our other equation. E, the cell, going to equal E naught cell minus RT over ZF ln Q. So we can go through and find Q first. This is coming back to that balanced equation that I had talked about. So Q is equal to the concentration of your products over reactants. So from the balanced equation, we're going to have iron 3 plus over iron 2 plus and silver plus. So these values here are the ones you're getting directly from the cell up here. So it ends up working out, you're going to have 0.2 over 0.1 times 1. Nice and simple, just gives you a value of 2. So if you're to plug everything back in over here now to find E cell, so this right here is what we're getting there, that's 0.011 volts. Over here, our gas constant, that's 8.314. Our temperature is always 298 unless I tell you not. Z comes directly from that balanced equation, and that was 1 electron. So it's just 1. You know Faraday's, and you have Q. So you should be able to solve for E naught cell to be 0.0288 volts. Now bringing this number back up here, we can solve for E naught of the anode. So I'll write that down here. E naught of our anode is now going to be 0.8 minus 0.0288. So your final value should be plus 0.77 volts.